Hey YouTube, JP here from New Zealand. I thought I'd just post a quick video on a fix I found for a problem I came across when I purchased the Jumper R1F radio receiver. So this little guy here is it's a great buy price. It's about 23 New Zealand dollars, probably closer to 15 US dollars, and it has a FPort output, which is fantastic. With FPort you can get bidirectional communication, which means you can not only get your receiver signals into your flight controller, but you can also get telemetry out with a single wire. And that's great, but it doesn't work with F4 flight controllers. And the reason for that is that F4 flight controllers do not cope well with inverted serial signals. So today we're going to learn how we can modify the Jumper R1F so that the signal is no longer inverted and we can get working telemetry and receiver signals to and from our flight controller. So stick with us. It's going to be a fairly comprehensive tutorial. It's not a simple process, but if you're careful and you're patient, you can make your R1F work and not have to throw it in the bin. So let's get started. Alright, so here's our receiver up nice and close. And you'll notice on here we've got our three connections here. We've got positive and negative, and we've got an FPort signal. So this is a bidirectional signal line. So information is going to come from the flight controller into the receiver, and also from the receiver back out to the flight controller. This is where it gets tricky. So if we look at the other side of the board, now we can see here we've got a bunch of different ICs, but the two that we're interested in are these two here, both labeled C045. So these are an inverting buffer. Each one has a single inverting buffer. So what that does is it inverts the signal, because the actual FPort protocol is an uninverted protocol. And that's a little bit frustrating because the native format of this protocol is actually supported by the F4 flight controllers, but Jumper have gone here and inverted the signal. So they've actually added components to invert the signal and created our problem. So what we need to do is we need to remove these two inverters. Now the reason there are two inverters is because, as I mentioned before, FPort is a bidirectional protocol. So it's half duplex, bidirectional, which means that the signal travels to and from devices on a single wire, which means only one side can be transmitting and the other side receiving at any one time. So there's a little bit of circuitry on the other side of the board, which we won't go into, that helps to handle that communication. So by linking across these chips and removing them, we stop that inversion from happening, but we leave the ability for the receiver to switch between receiving and transmitting signals. So that's the first thing we're going to do. We're going to remove these two ICs, and we're going to create a link from the input to the output of each IC. Then lastly, on the top of the board here, we have, so this is a uninverting buffer IC. This one is going to stay on the board, but what we're doing is because we're uninverting the signal, we actually need to change the idle state of the signal. So the idle state for an uninverted signal is for the voltage on the line to be high, or logic 1, which in our case will be 3.3 volts. And this chip actually lets the inverting ICs we'll be removing handle that. So what we need to do is we actually need to pull the signal up manually with a little pull-up resistor. So I'll also show you how to do that, and we're going to do that around this component here. Right, let's head over to the soldering iron. Okay, so we've got the board now over at the soldering station, and we're going to remove these two ICs. Now the first thing you want to do, and this is not mandatory but it will make life a lot easier, is just to put some flux on the areas we're going to be reflowing the solder. And what this will do, it will help the solder to reflow much more easily, and it'll stop quick oxide buildup, which actually makes the soldering process a lot more difficult, and it will give us a much cleaner result in the end. So I'm just going to smear a little bit of flux here on all of the legs of these two ICs. There's a couple of ways that we can do this. One way, if you only have one soldering iron, probably the easiest way to do this is to take a very sharp craft knife and to actually separate the legs from the body of the IC. And this is actually not too hard if you do it very carefully. So here I would just take this knife in and I would just bring the knife right up flush against the side of the body of the IC, and just carefully, with a little bit of pressure and a little bit of forward and backwards movement, just slowly sever those legs. And once that's done, the body of the IC, the black plastic part, will just pop out, and you can actually just desolder each leg one at a time, and it's quite easy. If you do happen to have two soldering irons, or even better, some surface mount hot tweezers, what you can do is you can remove the IC all in one go by heating both sides of the IC at the same time. So that's what I'm going to do, because I have two soldering irons. Okay, so I've got a little bit of solder on both irons now, and very carefully not to damage other components, I'm going to reflow that solder and remove the IC just like that. So let's take this second IC. You can really see how helpful that flux is, and just helping for that reflow to work nicely. Okay, if you've made it this far, the next part is the real tricky bit. The pads on these ICs, as you would have seen, are very small and very close together, and we have to join two of them on opposite sides of the IC together. So the way I'm going to do that is I'm going to take some solid cable from a Cat5 Ethernet cable. You could use something similar, or you could use just some copper straight off a wire, but you want something that's very small, probably 24-26 gauge absolute maximum. So this is the wire that I'm going to be using, if you can see that. So what we're going to do is we're going to strip this back, take all the insulation off, and then tin the wire so it's ready to be soldered, and then bend it into the shape that we need, and then we're going to carefully solder that onto the board. But we're going to leave the wire attached to the longer length for the whole duration until we're absolutely satisfied that our solder joint is good, and then we can snip the tail off at the end. And the reason for that is it's very hard to hold the wire in place when it's such a small little link and we're reflowing the solder. So let's head back to the soldering station, and we're going to prepare this wire, and then we're going to attempt to solder it on. Okay, so we're back at the soldering station, and I've created my little lightning bolt shaped piece of wire. I'm just going to offer that up now to see whether that is going to work, and that looks about right. So this is the real fiddly part. Now notice I'm going to start with the pads that are located towards the center of the board for this IC, and the reason for that is because if I do the other one first, I'm going to block myself in and make it actually harder to do this one afterwards. So I can do this one first, and then I've got plenty of room to do the second one. So we start off with the first one. I'm just going to trim that back just a fraction so that we've got our nice lightning bolt shape. Not that way, this way. So we're interested in pad number 2 and pad number 4. We need to connect these two up. Okay, now once I'm happy with that, I am going to again just coat that wire in a little bit of flux just to make things reflow more easily. And then I'm going to just offer it up and use a bit of my blue tack just to hold that in place. Get that to a point where I'm really happy with the alignment location. I'm going to use the blue tack to steady the wire, and just use my finger on the wire, which you can't quite see off camera, just to really fine tune that location, and then reflow. Now that wire appears to be appears to be secured at both ends. But we're just going to have a closer look at that before we go cutting off the other edge. And so the way we do that is just by bringing the board up onto its edge like this, and we can have a look at the side. So I just need to focus that. Okay, hopefully you can see that, but we now have a good little solder joint between those two pads. Okay, here we are back on the other side, and we're just going to repeat the same process. Some more flux on my wire link, and I'm going to hold it as steady as I can and reflow the joint. Alright, that was a little bit messy, but let's see what we got. And that looks okay. Looks like we are soldered to both pads, so we can snip the tail off. Now, for this final step, we need to pull up the signal line so that in the idle state it is sitting higher. So the way we do this, we need a resistor which is going to pull up the line. So if we follow this signal line around here from the FPort, we can actually see that it makes its way around to this pin here on this buffering IC, and this pin here happens to be our 3.3 volt power supply to this IC. This is really convenient. It means that we can connect a resistor across here, and that will pull up our signal. Now, you might not have a surface mount resistor. You can use a standard leaded resistor or any kind of resistor as long as you can solder it between these two leads. So I've got this little surface mount resistor here, and the value of this resistor is not critical, but it should be between probably 2 kiloohms and 10 kiloohms. I've gone shot for the middle. This is a 5K6 resistor, and so I'm just going to solder it in place here. Now, if you've never soldered surface mount components before, these are not too bad. The hardest part is actually holding the component in place while you're soldering it. So again, we are going to just add a little bit of flux, which I should have done before I moved the IC. That will make our job so much easier. Alright, now I'm just going to make sure there's a little bit of solder on the end of my iron, just a very small amount, end of my soldering iron tip. I'm going to very carefully hold this resistor in place and just reflow one side there, just to tack it on. Alright, now that is functional, it's just a little bit ugly, so I'm going to attempt to do that again and just straighten things up. So there we go. It's not a whole lot better, but it'll do the job. And then the other side, a little bit more solder maybe. Okay. And we are good. So we can see the solder has flowed nicely on both sides of the joint, and we have a good pull up there. And that's it. We're ready to connect to our flight controller. You may want to clean up some of your flux with some isopropyl alcohol, as flux can be corrosive and cause damage to your components and printed circuit board over time, depending on the flux that you use, of course. But we're now ready to connect to our flight controller. So if you haven't yet configured FPort receivers in Betaflight, it's a fairly straightforward process. All we need to do is connect to our quad. First thing we're going to do is set up the ports. So in my case, I'm using TX1, which is on UART1. So I'm going to enable serial receiver, serial RX on UART1, and hit save and reboot. Next, we're going to come down to the configuration tab and scroll down until we get to the receiver section. we're going to select serial-based receiver, and FreeSky FPort is the protocol that we're using. Lastly, we want to turn telemetry on, and we can save and reboot. And that's it. It should be all up and running if you've done it correctly. Okay, so we have our R1F all modified, and we've now got it attached to our quad. And in this case, I'm using the diatone Mumba F405 Mark II. And so I've got this connected to 5 volts and ground, and our FPort signal is going to TX1. And so you might need to check which connections are suitable for your board. But in this case, it's an uninverted port on the F4. So here is my Radio Master TX16S, and we're just going to bind this receiver. So first of all, we start off by heading to the model, and I'm just going to head up the list to bind. And so first of all, we've got our mode is FreeSky D16, and our channel range is 1 to 16. Our receiver number is I've already got a receiver on this, so I'm just going to change this to number 1. Then I'm just going to hit the bind button. Now before I do that, I'm going to put the receiver into bind mode. So we're going to switch over to the receiver now. So here's our receiver. To do that, we're going to power it up. And while we're powering up, we need to be holding the bind button down. So the bind button is this little one here. So I'm just going to hold this down and attempt to connect the battery at the same time, which is always a challenge. So holding that down and connecting the battery. So we should be in bind mode. Start binding on the transmitter, and I'm going to go channel 1 to 8 telemetry on. And we've now got our LED flashing, so we're going to restart the transmitter, the drone, and we should find that we have a bind. So we've got a solid red, and our flight controller is no longer complaining. Now, if we come back to our main page, we can see straight away we've got our connection quality, which is standard. We would have got that regardless, but we also have our battery voltage, and we can have a look at our current or any other telemetry that your flight controller can send. So next, I'm just going to show you that we've definitely got controls happening by connecting this to Betaflight. Okay, so we have Betaflight open. We're going to connect to our aircraft, and we can see here that we've got the aircraft front page. If we come over to our receiver tab, we can now see that we are indeed receiving signals from our transmitter. And that's really it. We've proved that it's up and running. We've got receiver signals coming through, and we have got telemetry coming back. As far as I can tell, there are no restrictions on that telemetry. It's all the same as if you had a FreeSky R-XSR, and it just works. So that's it. You've successfully completed the Jumper R1F modification for the F4 flight controller. I hope you were successful. If you're having difficulty or if you have any feedback, please feel free to post it in the comments, and I'll do my best to get back to you. Cheers guys, have a good day.